There. Alright, this is going to be our first video for actual chemistry content. I promise I'm not a teacher who just reads from the slides, but it might seem like that for today as we all adjust to the new normal. Anyway, as you can see, chemistry is the study of the composition, structure, and properties of matter and the changes it undergoes. Just in case you don't remember from 9th grade physical science, remember reactants are on the left side of the arrow and products are on the right side. You will be expected to know this. The first bit here is just a bunch of definition type things. Matter is anything that has mass and takes up space, and mass is the measure of the amount of matter. An atom is the smallest unit of an element that maintains the properties of that element. It can still be broken down, but it just won't have those properties anymore. Elements are pure substances made of only one kind of atom. Now the symbols for these elements can either be 1 or 2 letters. When the symbol has 2 letters, the first one is always capital. An example you probably can't see right here is chlorine. The C is capital and the L is lowercase. That is not a capital I. Moving on. A compound is defined as a substance that is made from the atoms of 2 or more elements that are chemically bonded. A reaction is represented by a chemical change, and that's how compounds are made. This is what sucrose looks like in its ball and stick model, also known as table sugar. Here's a couple of more definitions for you. Extensive properties that depend on the amount of matter that is present, and intensive properties basically do not depend on the amount of matter present. So, 3 examples here, we're talking about volume, mass, and energy content. So if we're saying that it depends on the amount of what you have, I have a volume of water in this water bottle, and if I pour some out, I have less water in the water bottle, right? So it depends on the amount present. So that would be an extensive property, and that's how we know that volume is an extensive property. But if we took the boiling point of this water, it would still boil at the same temperature that it did when there was more of it. So the boiling point never changed. That's why it's an intensive property. All right, getting into more important stuff here. A physical change is a change in a substance that does not involve a change in the identity of that substance. What you want to focus on here is that physical changes are often reversible, meaning you can go back to the original substance. Like phase changes, for example. When something melts or even evaporates, you can absolutely go back and condense it or freeze the substance to get it back to its original form. Okay. This has a lot of information about the particles inside the different phases. Basically, when something is a solid, its particles don't really move much. They can kind of vibrate back and forth, but they're more or less locked in place. When something is a liquid, the particles can move. They're not locked in place, but they have to be pretty close together. Now, when we continue adding heat, we can get something into a gas phase. These particles can be very far apart. And finally, in a plasma, everything is ionized, it's extremely high temperature, and mostly found on the sun. Now, these are just to give you a picture of what these particles are doing inside these substances. Notice the difference in the amount of motion of these particles. They're moving back and forth, they're kind of vibrating, but they can't really go anywhere. This is the solid phase. And in the liquid phase here, they're moving around a lot more, but they're not exactly far apart like they are in the gas phase right here. This is just to give you a little picture of that. Okay, on to much more interesting topics. A chemical change is a change in which one or more substances are converted into another substance. The big difference here from physical changes are that chemical changes are often not reversible. These changes are much more permanent. Some evidence to know if a chemical change has happened are when heat or light are given off. All right, this is what we will use for our first content assignment. This is a flowchart you will need to use in order to classify matter. So if I ask you about something like table salt, which is NaCl, sodium chloride, you will ask yourself a few questions to determine what kind of matter it is. You will first ask yourself if salt can be separated physically. Like, can you pull apart the sodium atoms from the chlorine atoms? This might sound silly, but of course you can't. The next question here is asking if you can separate the sodium from the chlorine chemically. Sure we can. We can make it undergo a chemical reaction. So we would say no to physical means. We're in pure substances. Can it be decomposed by ordinary chemical means? Yes, we are into compounds. So this puts table salt down here under compounds. That's how this flowchart works. I want to do one more example with you. Although you might think of air as only one thing, it is actually a mixture of gases that can be separated based on their densities and boiling points. Okay, so back to the first question. Yes, you can. This means it is a mixture. Then it asks you if the composition is uniform. This just means whether it looks all the same or not. Basically, can you see a difference between the oxygen atoms here and the nitrogen atoms over here? No. That makes it all uniform, meaning that air is a homogeneous mixture. Here are your definitions for these mixtures, with another example of a homogeneous mixture. So like it says, chocolate milk. You cannot see the difference between the chocolate and the milk particles when it is mixed, so that makes chocolate milk a homogeneous mixture. But here is an example of a heterogeneous mixture. If you follow the flowchart, the first question is, can it be separated by physical means? This is asking if you could separate the yellow bits from the green bits from the red bits. Could you, if I gave you a magnifying glass, tweezers, and several hours, I'm sure you could do it. So yes, it is possible. Next question. Does it all look the same? Well, no, of course not. There are green bits and yellow bits and red bits. So this means that it is a heterogeneous mixture. Another example of a homogeneous mixture is marker ink. And I actually plan to do a lab or a demo so you can see exactly how we separate this and what it's made. One final example of separating a homogeneous mixture is distillation. Now, don't tell your parents I taught you how to make alcohol, because that's just not true. I'm telling you how to purify the alcohol once it is already made. It's different. Oh, and if you've ever seen the show Moonshiners, they would probably be very familiar with this process. Anyway, let's say you have a mixture of alcohol and water here as the purple liquid in this distillation flask. So what you're going to do is boil it, but at a very specific temperature, a temperature slightly less than 100 degrees Celsius. Where the alcohol will boil, the water will not. If the water is not boiling, the water will stay behind in the flask, right? And what does boil is pure alcohol. So the alcohol becomes a vapor. It's going up here and tries to get through this tube, but we have a stopper on it, so it can't get out. It is then forced down this tube to the right, where it hits this cold water on the outside of this tube. The cold water condenses the alcohol, changing it back from a gas to a liquid, where it can finally drip out into this flask here. Now what collects down here is pure alcohol. Thanks to our understanding of separating a homogeneous mixture. Oh, I was wrong. I have one more example of separating a homogeneous mixture. In this one, water is being separated into hydrogen gas and oxygen gas with this battery here. We hook it up to the water, and I actually have a YouTube video for you to watch about this. We hook it up to the battery, and it produces hydrogen gas and oxygen gas. And since there is twice as much hydrogen in water, because it's H2O, it produces twice as much hydrogen gas as oxygen gas. And as you can see from the reaction down here, we have water produces H2 and O2, hydrogen gas and oxygen gas, and there is a 2 in front of the H2 because it produces twice as much. Okay, there's not too much more before we are done with note 1. What this means is that you guys are basically ready for activities 1 and 2. Look for those to be on Schoology very soon. Okay, so we can't have a chem class without talking a little about the periodic table. We will go much more in depth, but for right now, we need to know just a few things. First, rows are called periods, and they go left to right. Groups are columns, can also be called families, and they go from top to bottom. Now, just a few notable groups here to note. Alkali metals are in group 1, alkaline earth metals are in group 2, transition metals are all in this area. Are we noticing a pattern yet? Most of the periodic table is actually made of metal. A couple other groups over here. Group 7 is halogens, and group 8 are the noble gases. But let's talk more about metals. Here are some properties of metals. Metals are good conductors of heat and electricity. They're malleable. This means they can be bent or hammered into shape. They are ductile, which means they can be drawn into wire. They have high tensile strength, and they have luster. This just means that they're shiny. We're not going to talk too much about alloys, but just know that it is a solid solution, which makes it kind of a weird type of mixture. You're probably aware of a couple alloys like brass and bronze, which are a mixture of copper and zinc, and a mixture of copper and tin. Here are a couple of examples of metals from the periodic table before we move on to nonmetals. Nonmetals are poor conductors of heat and electricity. They tend to be brittle, and many of them are gases at room temperature. And here are a couple of examples of nonmetals from the periodic table before we move on to our last section for now, metalloids. Metalloids are kind of a mixture of metals and nonmetals, and what their properties are kind of depend on which metalloid you're talking about. Metalloids are more brittle than metals, less brittle than most non-metallic solids. Metalloids are semiconductors of electricity. Some metalloids possess metallic luster, but most do not. Silicon is one that does have luster, but it is brittle like a nonmetal. Since it is a semiconductor, it is heavily used in computer chips. All right, we are done with note 1, and in my class, what that means is we are ready for a quiz over this material. I know it's a bit early for that, but let's start with activities 1 and 2. You should be completely ready to get those 100% correct, and if you need any help, make sure to let me know. You can send me a Schoology message or an email or a remind text. I'll get you the help you need, or you can ask me questions during our scheduled class time in a Google Meet. I look forward to seeing your completed assignments, let's say by Friday. Thank you so much. Moving on. Compound is defined as a substance that is made from the atoms of 2 or more elements that are chemically bonded. I'm probably going to have to record that again.